Welcome back to the Apcon Technical Training video series. This is the 8th of 9 Apcon Partner Training modules. In this module, we will run through a software demonstration of Apcon's WebX single switch management and Titan EP multi-switch management software.
What we're looking at here is the login window that you receive if you point a browser at one of our switches. So I'm going to go to the switch first. This is likely what most people would use if they have a 1 or 2 switch deployment without any scheduling or reporting requirements that you find in Titan. So I will go ahead and log in here. In our demo environment, we are authenticating against a Radius server, but we're also compatible with TACAX Plus and LDAP, and even there's an internal database if none of those capabilities are available that can be authenticated against. The way this works is the Command Center button is sort of like a main menu, and you have various options off of here. I'm now looking at the WebX option, which gives us this ribbon of functions up here. I'm in the ports display right now. So we're looking at a representation of the front of the chassis. This is a 1RU chassis that has our 3030 E36 6-blade installed in it. Now, we're not equipped in our demo environment to actually pass traffic through. In fact, many of our ports don't even have SFPs in them, so that's what this X means, is that there is no SFP plugged into it. In this case, there is an SFP installed here, and this logo, this icon indicates that this is being used as a trunk port for a connection to another switch. And I want you to notice when I hover over it, this tooltip window comes up, and that's a user-definable port name that's being displayed there. So you can define these to reflect what we're connected to, in this case FireEye or T-Leaf or span ports. These little shield icons indicate that these ports have been assigned to a certain class that limits what type of ports it can be connected to. Span ports, I don't know if you've ever connected 2 span ports together, but it's really unhealthy on a switch to have that happen. So we've implemented this way to protect certain ports from inadvertently being connected to similar ports where it might have an adverse effect on the switch or router. Now, this is a simple interface for making connections. What I'm going to do is I'm going to say that we want to aggregate port A13 and A14 together. What I did is I just clicked on each one and turned them blue. We use blue to indicate ingress ports. So these are going to be ports that we receive data from a TAP or a span port. When I'm done selecting my ingress ports, I'll click Set. And now I choose my egress ports. Maybe I want it to go to all 4 of these tools. And then I confirm. So this is what's about to happen, taking data streams that we receive on these blue ports, aggregating them together, and sending that aggregated stream out these 4 orange ports to monitoring tools that are plugged into them. This is a good place, if I need to apply a filter to either my ingress or egress ports. Each port has an individual filter that can be defined. You'll notice there's a list of filters that have already been saved. You can choose from filters that you've already created, or you can create them on the fly. And this is what that looks like. When you're creating a filter, the first thing you do is decide whether you're going to pass or drop packets that meet the filter criteria. And then you build a Boolean equation based on aspects of the packet headers from layer 2 through layer 4. For example, if I want to filter on web traffic, I'm going to build a kind of a nonsensical filter here just to kind of show some of the features. You know, one thing that that I like to point out is when there are certain headers that utilize code that you might not necessarily remember, we do offer a drop-down list, so you can choose whatever kind of, you can choose from an English language selection rather than trying to remember the codes that you'd otherwise have to specify. I'm just going to pick something that doesn't make sense here. You go ahead and build, if you need to create a nested equation, you can then add your Boolean arguments here and continue to go. You'll notice as I'm doing this, it's creating the filter down here in Berkeley packet filter syntax, which is what Wireshark uses. As I mentioned before, if you're more comfortable with Wireshark, or if you have filters that you've already created, you can type those or cut and paste them into this field and do it that way rather than using the GUI if you're more comfortable. When you save this, you would give this filter a name, and it would be stored in that pick list so that you could use it on other ports if you like. I'm not going to save this because obviously it doesn't make sense, but that's how you create and apply filters on ingress and egress ports. Here is also where you can decide to remove the outermost VLAN from an incoming packet. Some applications that may make sense. Or on your egress ports, you can decide to enable port tag. If you'll remember, port tags allow your monitoring tool to determine which port a packet originally came from when it came from an aggregated connection. If I enable port tags, each packet coming through this egress port would have a VLAN tag of 14 applied to it, so that your monitoring tool would be able to filter off of data specifically from this incoming port. When I apply, that connection becomes active. And you'll notice when I hover over it, it lights up showing me that these two blue ingress ports are being aggregated together and sent out these 4 egress ports. So that's essentially how you make connections here. Now, being a Flash application, there are menu items if you right-click on each individual port. In fact, I'm going to do it on one of these ones that has an SFP installed, because one of the features that are available is port statistics, where you are able to see how many packets per second are going through that port. We have counters, including one that shows you, if you have a filter applied, how many packets are matching the filter, and Armon statistics, including how many packets are being oversubscribed. All of those things are SNMP gettable. Let's see, you can adjust for each individual port. You can set thresholds that can inform you if you are approaching an oversubscription condition. This would allow an SNMP trap to be sent so that you'd be notified. It also stores it to the system log of this switch. If you are monitoring data from a tap, you might want to enable your lower limits. In case anything goes wrong with that tap, you could get informed that there is no data coming through that port anymore. So a variety of capabilities are available here. You can lock the connections so that no one else can disconnect the patch that you just made. You can configure the lock to expire. And you can configure it so that the connection you made will automatically break down once the lock expires. There's a variety of capabilities available there. Up here on the top menu, we also have a view mode. This is a really good mode to use when you want a quick snapshot of all of your connections in the switch. You can see how much traffic is going through the individual ports. It's very helpful when you have a chassis with a lot of blades in them, because it condenses the information into a smaller space and gives you the same information you need. You can tell that A13 and 14 are being aggregated together and sent out these destination ports. If I was applying a filter on any of these ports, they would appear in this column. So it's a very convenient way of looking at the ports. You can disconnect ports from connections if you wish, and you also have the ability to look at port statistics and access to these other features as well. So that is the view mode. Global view is where you can go to make use of the diagramming feature that I mentioned earlier. You'll recall diagramming is sort of the Visio-like interface. I'll go ahead and create a new one here. You give the diagram a name. You have over on the left all of the ports from your from the blades in the chassis available, and you simply drag them into the drawing area. Here, these will be my source ports, tap ports. Let's say I'm going to send them to here, and then I use these drawing tools to create the patch. Now, I'm not enacting this patch as we speak. I'm just creating a diagram of what I want to apply. If I apply this, this connection will be created, and you'll begin passing traffic from these two ports, aggregating them together and sending them to this monitoring tool. But one of the real strengths about the diagramming mode is that you can save this to apply in the future. This might be a configuration that you don't want constantly in operation. So you can save it to a library of diagrams and apply it when you need it. Now, if I wanted to send this data to a load balance group, this is where I do it. I just click Add Load Balance Group. These are the ports in the chassis. I choose how many I want to have in this load balance group. I can do up to 8. Type a name for it, and it becomes an object in the diagram that I can then connect into my patch. So what's happening here is I'm taking data from these two tap ports, aggregating the data together, sending the entire data stream to this tool, and sending it also to the load balance group, which will even out, it will evenly distribute those packets across all 8 of these ports to whatever monitoring tools are plugged into them. It's very simple to build patches and load balance groups in the diagramming mode. Other features are the status section gives you an overview of status of the switch. Very clear to see what's going on. They are sensitive areas that give you information about your controller. You can see your IP information. So very GUI oriented, very simple to use. NetVids we discussed a little bit earlier. This is an optional software package that can be added to the switch. This allows you to define ports as either data sources or destination tools, so they can be divided into 2 simple panes, allowing you to make connections as easily as this. I think that's going to, let me undo that one, yeah. So there we go. So we're going to aggregate these 2 sources together and send it out that port. A couple of points in the admin section, the global settings. This is where you go to perform firmware upgrades. This is your backup and restore section. You define your users here, including deciding what type of user gets access to which aspect of the switch. So it's very granular control over what each type of user can get access to. Now that's a quick overview of the individual switch. Now what I'm going to do is log out of here because I want to show you to contrast that with this. This is an IntelliTap, I'm sorry, IntelliStore. As I mentioned, it also is very similar, same capabilities for aggregation and filtering, the same method of creating the connections. But here you have two hard drives on the blade itself that can serve as destinations. What's been established here is these two ports are being aggregated together and being sent to that drive. But if I want to take something from this port and make a quick capture, I might not be able to, well, someone's been using the system and I don't want to mess up what they've been doing, but you simply make a connection to the drive and set up your recording parameters, including when you want the capture to start, how much data you want to capture. You can define a filter for the type of packets you're looking for. You can even define a filter to trigger the capture so that capture will only occur if a certain type of packet is observed. Now once you've made a capture, the resulting PCAP files are available here so that you can easily download them and view them on your computer. If you don't have Wireshark or a PCAP compatible analysis tool on your computer, you can launch Wireshark from clicking on this button. It will launch a separate window in your browser with a session of Wireshark right there and present the PCAP file to you. That's a quick overview of IntelliStore. Now here's Titan. This again is the multi-switch management application, running either on an appliance or a virtual environment, and you'll see a lot of similarities. We are in the ports display, where we are looking at data sources over on the left, destination tools on the right. What's new about this is this center pane, which shows you trunk links going between switches in your multi-switch deployment. So what we're looking at are ports from a variety of switches. You can sort through them over here on the left. You can create a multi-tiered menu structure or Explorer type interface using custom designed names. You can name them after sites or user groups and filter the switches you're looking at by clicking these buttons. You can also do it by switch. In this case, I'm going to choose to look at just these two switches. So now I've got two different switches being displayed here, this 3036 and the 3072. These are the data source ports that are available. Over here are the destination ports for those two switches. And these are the trunk ports that go between these two switches. Making a connection from one of these switches, say the 3072, we will aggregate these two TAP ports together and send them to this monitoring tool on the 3036. Send it to, yeah, this one. All I do is click on this source, this destination, click confirm. This is what I'm about to do. I don't have to worry about how the data is getting there because Titan keeps track of the trunk ports between those two switches. At this point, I can choose to schedule this connection, either do it now or at some point in the future. I can choose for it to remain active indefinitely or a specific time or date that it should be disconnected and potentially broken down. A lot of the same features we saw before here. You can apply a filter to these ports. You can enable port tagging, very similar to what we saw in the individual switch itself. The difference here is that you've made a connection from one switch to another without having to focus on how it got there. Titan automatically chose which trunk to use. it saves several steps if you are going from one switch to another and without the benefit of Titan. Other features specific to Titan are this, we mentioned the scheduling capability. Here's where you can get access to the calendar to see what types of connections are scheduled. And there's a reporting capability where we can look at things like switch utilization, how much data is going through which ports. You can get a report of what connections are currently established, what's installed in each chassis, and how they are configured. And in each case, when you specify specific switches that you want these reports for, you can save them for reference in the future. So this is our reporting module. The rest of the features in Titan are very similar to what we saw on the individual switch. So if you understood what we were looking at there, then this should be intuitive. We're looking at how the patches are created, including the amount of data that's traversing the connections. So that's a quick overview of Titan and the features that distinguish it from the WebX interface of the individual.
Thank you for watching this Apcon technical training video. You may share this video with your customers to illustrate the convenience and power of Apcon products. The next video in the series is Module 9, Building a Bill of Materials for Apcon Products.